Hello, in this video we are going to solve question number 36 of GATE 2016 physics paper. Uh, this question related to Fourier series from mathematical physics. The question is, a periodic function fx of period 2 pi is defined in the interval x ranging from minus pi to pi as this particular, which is given in the question. So the Fourier series expansion of this fx is. Now, any periodic signal can be represented as a linear combination of sines and cosines, which is nothing but the Fourier series expansion, or mathematically it can be represented by this equation. Cos of n pi x by L plus summation n is 1 to infinity bn sine of n pi x by L. So any periodic signal can be represented as a linear combination of these sines and cosines up to infinity, where this L is nothing but half period of the function an and bn are the Fourier coefficients. And these coefficients are given by a naught is equal to 1 upon 2l minus l to l fx dx. Now this quantity represents nothing but mean of this periodic function fx. Similarly, an is 1 by l fx cos of n pi x by L dx, and bn is 1 by L minus L to L f of x sine of n pi x by L dx. So we just have to calculate these three Fourier coefficient and put it into this equation, and then we'll get the Fourier series expansion. So for this given question, if we just plot it, minus pi to pi is the limit of x. So from minus pi to 0, it is minus 1. And from 0 to pi, it is plus 1. So this is a function. So this is a kind of, fx is asymmetric in nature. It's asymmetric about this point, origin. And for asymmetric function, the coefficient a naught, this integral will vanish out from the limit minus pi to pi, because this is odd function. Similarly, your an will also be turned out to be 0. So both these terms, coefficient a naught and an, just because the fact that the function is asymmetric, therefore both these integral will vanish out. So we will only be left with bn. We can also show this by just calculating these three coefficients in this question. A naught is nothing but 1 upon 2 pi, the half period function is pi, minus pi to pi, fx dx. Just decompose it into 2. So minus pi to 0, it is minus dx, and from 0 to pi it is plus 1, so dx. Just integrate it, and what you will get is minus of 0 plus pi. You just integrate it, plus pi minus 0. So these terms will vanish out, you will get 0. Similarly, when you calculate an, you will get minus of cos n pi x by L. L is here is pi dx plus 0 to pi cos of n pi dx. Now you will just integrate it, so you will get 1 by pi minus pi to 0 cos of nx, there will be minus n also, cos of nx dx plus 0 to pi cos of nx dx. Just integrate both these terms, so we get sine of nx 0 to pi plus sine of nx upon n. Zero to pi. So you'll just take in common, so you'll just, what you'll get is 0 minus sine of pi plus sine of pi minus 0. So sine of pi is always 0, so this is also 0, so an is also 0. Similarly, we can calculate b, which is come out to be 1 by pi, disintegrated sine of nx dx plus 0 to pi sine of nx dx. You just integrate it and just calculate it. What you'll get is 1 by pi cos of nx by n 0 to minus pi plus, minus cos of nx by n pi to 0. Take n common, so you'll left with 1 by n pi 1 minus cos of n pi minus cos of n pi plus 1. So you'll finally left with bn is equal to 2 upon n pi 1 minus cos of n of pi. So this is your answer. Now cos of n pi, we can write cos of n pi is equal to 1 for even n minus 1 for odd n. Therefore coefficient bn is equal to 2 upon n pi. We can write this cos n pi is nothing but minus 1 to the power n. Therefore bn is 0 for even n, because for even n cos n pi is, this one will just become 1, so it will become 0, and for odd n it will become 2 times 2 n pi, so 4 upon n pi for odd n. Therefore our Fourier series solution, which is fx is equal to a naught and a n are 0, so these two terms will vanish, only we will have third term bn, and that too only for odd n. So we'll left with sin x. Even terms will vanish because for even n it is 0, and sine of 3x by 3 plus sine of 5x by 5 and so on. Therefore our answer is option A. Option A is the only which satisfies all these options, so option A is correct. Thank you for watching this video.